Hey guys, so it's been about 10-15 minutes and our gel fragments are hopefully melted right now, so you can hold them up to the light, shake them, and you can tell it's going to be really hard to see on the camera, so I won't try. Well, maybe we'll try. But you can shake it. I don't see any fragment in there, so that one's melted, and hopefully these two are melted too. If you shake them, you can see the kind of like an oil mixing with water. I don't know what it's called, but there's these like, it almost looks like when you see the desert ground, how you see the little heat waves. You can see that kind of effect in here, and that's telling you that the gel is mixing up with the ADB. So these are all good. All of our gel fragments are melted, and now we're ready to actually purify the DNA out of these tubes. So a quick note. 2 of these samples that you saw earlier on the gel were vector backbones, and they were digested, and they were very strong. This sample right here, this is our part, and this is a small fragment. That means we can't treat it as we would a normal part, because if we do, we'll lose it. So we need to do a small fragment gel purification. So you always want to pay attention, and if I had been cognizant, if I had been paying attention, I probably wouldn't have run it on the gel. I would have just done the small fragment purification on a zymo column straight up, but that's okay. I already did it with Sabadan. So whenever you're doing a small fragment cleanup, you always want to add in about 1/3 volume of isopropanol or ethanol. I generally use 100% isopropanol. So I added 750 in here. So I'm just going to add about 250 of isopropanol. So take my P1000. Actually, I misspoke. It should be 1/3 volume of ADB and 2/3 volume of isopropanol. So I've already kind of messed up the formula here, but in a testament to how robust biology really is, this will still work. We'll still be able to get away with it. But the right way of doing this is about 1/3 volume of ADB, 2/3 volume of isopropanol. So I'm just going to add my isopropanol here, and then you're going to see a big color change. It's going to turn kind of yellowish, maybe. So if I rock it, you can see it kind of turned yellow, and there's some stuff that's precipitating out, and that's just precipitating out all the nasty, gross stuff. It's going to get in the way of our small fragment purification. So I'm actually going to add a little bit more isopropanol, and this is kind of a testament to how ad hoc things can be, and you just kind of got to get a sense for what things look like. I'm definitely not going by the book right now, but generally you do want to in the very beginning. This should still work, no problem though. So now you can see there's a very nice yellow. If you look closely, I don't know if the camera can pick that up, but there's like some chunks in there. That stuff that's just precipitated out. So now we're ready to do the purification. Now I have a huge volume in here, which means I'm probably not going to be able to get that all through on one spin, so I'm going to have to do 2 spins. So I'll just load everything up and take my P1000, set it to about 1000, and generally you just want to load up about 700, 800 microliters onto a column at one time, but I'm just going to kind of go until it looks about right. It looks like we're having an ad hoc type demonstration here, so that's about the max you want to get, and then switch tips, and load our vector in. Vector 1 and vector 2. Then we just spin it down for 30 seconds. We're just going to do 15 seconds just for time's sake. So in this centrifuge, I just put it in, skip 3, put it in the next tube, skip another 3, put it in the next tube, and then gives us a little triangle. Cap it, close it, hit start. And while that's spinning down, I'm going to get my PE buffer, which is our rinsing buffer, or our washing buffer, ready to go. And keep that next to the centrifuge. But because we couldn't fit all this in the first time, we're going to do 2 initial spin down steps. So first spin down step is completing right now. I'm going to bring all my materials close. And going to empty all of our tubes out. So looks like this one didn't even go all the way through. 1, So I only spun this for 15 seconds, so this will show you kind of what happens when you do that for 15 seconds. It might not spin completely through. This one also has a bunch of gunk, which is just no good. So it gives me an opportunity to load the rest of our small fragment. And now we're actually going to run this one for 30 seconds, and hopefully that should all get through. So depending on how much ADB buffer that is what happens when it's unbalanced. I probably should have done a better job of balancing that. It'll be okay though, it'll survive. So, where was I? Oh yes. So depending on how much ADB buffer you're using for the gel fragment, you may get a thicker or a thinner type of mixture. So if you have a huge gel fragment, if you had a huge band and you couldn't trim off too much of that gel, and then you melted it in 750 microliters of ADB, you're going to get a thicker type of mixture. Whereas if you had a smaller band and you could trim off a lot of that gel, and you mix it in that same volume of ADB, you're going to have a much thinner mixture. And those thinner mixtures they spin through a lot easier. So again, this guy's just not wanting to go through. Let's see if I can't just spin it another 30 seconds. So this is not normal. This is probably why you want to stick to the procedure and why ad hoc does not always work. So give it another 30 seconds, and if it hasn't gone through by then, I'm just going to pull off the rest, give it a rinse, and that should work. We've already had enough flow through to bind some of the DNA to our membrane. And at this point, we're just going to be getting a little bit more. And so what's happening here is that when I added the isopropanol, I precipitated out some of the DNA, and that precipitate is getting clogged and stuck on top of the membrane. The PE will dissolve all of that, though. Okay, now we're going to start our wash steps. This is kind of a good example of how you have to adjust your protocol on the fly. You can see we got a little bit more through, but at this point I'm just going to pull off the rest. There we go. Now we're going to add 250 microliters of PE to each reaction. We're going to do this twice. And we're just going to spin for 15 seconds now, even though you should be doing 30 seconds each time, but just for the sake of saving time for this demonstration, 15 seconds will do it. 1, 2, and 3. Cap it. Close it. And hit start. Always remember to put the cap on, otherwise it makes a terrible racket. Another thing is you always want to make sure it's balanced. Touch on that earlier. Balance in terms of the pattern of the tubes that go in. And you also kind of want to balance the amount of liquid that's in them. You heard the terrible racket that I made earlier. That wasn't even that bad. If you have a full tube in one and an empty tube in the other, it can really start to mess up the centrifuge. Worst case scenario, the thing would explode, though. I have trouble seeing that happen.